Hello everyone, in this episode we're going to be creating a little game to practice some of the stuff that we've learnt up to this point. So how the game works is the computer will print out a random number of seconds, and then you have to sort of count down those seconds in your mind, and when you think the time's up, you hit the spacebar, and it tells you how you did. Okay, so in Unity, I'm just going to head over to the project window, and right-click, create new C# script, and I'll call this something like time game. And then maybe we can just quickly create a new empty object in our scene and just add the time game script to that. Let's just double click to open this up. So before we get started here, I just want to introduce a concept called method overloading. So what this is say we have a method called foo, which is just a sort of nonsense name used in programming examples. And say this takes in an integer x, and then all it does is it prints out integer plus the integer it was given. And then say we have another method with the exact same name, but this one takes in a different parameter, say it takes in a float x instead, and this one can print out float plus the value it was given. So now if I want to call foo, say from the start method, so I write foo, you can see in this little pop-up it says 1 of 2, and there are these little left and right arrows. So if I just press the right arrow on the keyboard, you can see that I can cycle through these two different versions. And once I actually start writing this, this changes to an up and down arrow, so we can cycle through like that. So if I pass in, say, 5, which is an integer value, let me save that and just quickly run. You can see it will print out integer 5. But if I just add an f onto the end of that to signify that it's a float value and run this again, you'll see it will run the float version of that method. So once again, this is called method overloading, when we have two or more methods with the same name, but they take in different parameters. We'll see a practical example of this in just a moment, but for now I'm going to delete all of that stuff. And in the start method, I'm instead going to print out some instructions for the game. So let's say I print something along the lines of press the spacebar once you think the allotted time is up. All right, and then we're going to want a method, a void method, to set a new random time. So void set new random time. Okay, so we obviously don't want the player to have to wait too long, so when we're generating this random number of seconds, we want to sort of constrain it to a range, say, somewhere between 5 and 20 seconds perhaps. So let's say int wait time is equal to, and then to generate a random number we use the random class. So we can say random dot, and then to specify a range to choose the random numbers from, we can just use the range method. And over here you can see the overloading thing I was just talking about. If we give it its min and max values as an integer, then it will return an integer value. But if we give it its min and max values as floats, it will return a floating point number. Note that in the summary of the integer version, we can read that it returns a random integer between min inclusive and max exclusive. That just means that if we pass in, say, 0 and 2, then the only possibilities for our random numbers will be 0 and 1, since it will include the minimum number, but it will not include the maximum number. So if I want a random number between 5 and 20, I'll pass in 5 and 21. All right. Now I'll just print out the wait time, and I'll just add on a string seconds to that. All right, and let's just call this from the start method, set new random time. Let's just quickly give this a test in Unity. So I'll press play, and it says press the spacebar once you think the allotted time is up, and it prints out a random number. Let's just try that again, and you can see we get a different number and another different number. So that seems to be working. Let's go back into MonoDevelop, and in the update method, we want to figure out if the player has pressed the spacebar or not. So last episode we looked at the structure of the conditional statement. So remember that's the if keyword followed by a pair of parentheses inside which goes the condition. And if that condition is true, then whatever code we put inside of these two braces will be run. So for the condition, we obviously need to supply a bool value, and in this case, we want that value to be true if the spacebar was pressed down this frame. So to get input, we use the input class, and I'm going to make a call to the getKeyDown method. As you can see here, this takes in a key code and returns true during the frame that the user starts pressing this key. So we'll want to pass in keycode dot, and when we say keycode dot, you see it gives us a list of all of the different keys we could press. So we want to choose the space key, and just make sure that you've got the right number of parentheses here. So we need these two for the getKeyDown method, and then these two on either end for the if statement. Okay, so when we detect that the space key has been pressed down, we're going to want to print out how much time the player has been waiting for. So to keep track of time, there is this time class, and this has got a time variable which keeps track of the number of seconds since the start of the game. So we're going to want to record what time we start this new round at. So let's create a float up at the top here called round start time. And remember, if we don't assign a starting value to this, it will just be initialized to 0. And then in the setNewRandomTime method, we can say round start time is equal to the current time. And now when we press the space key, we can say float player wait time is equal to time.time minus the round start time. Okay, then it would also be nice to know how far off the player was from the intended wait time. So currently we can't access this variable because it is a local variable. Remember, it's declared inside of a method. So if we just move the declaration outside of the method to over here, then we'll be able to access that value. So we can say float error, just meaning how far off the player was, is equal to the wait time minus the player wait time. Now obviously if the player waited longer than they were supposed to, then this will be a negative number, otherwise it will be a positive number, but we only really care about how far off the player was. We don't care if it's negative. So what we can do is use the mathf.absolute method, which just returns the absolute value of the given integer, or, once again, method overloading, float. So, in other words, it just takes a negative number and turns it into a positive number, simply by removing the negative sign. Next, let's just print out how long the player waited for, as well as how far off they were. So we can just say print, and we can say you waited for, then add the player wait time value. And we could just say that that's being measured in seconds. And then to tell them how far off that is, we can say that is plus the error value plus seconds off. Okay, and then we can start a new round by saying set new random time. All right, let's save that and give it a try. We're going to want some more space, so let's just move the console up here. Let's drag this out, give us sufficient room, and let's press play. So I'm not going to try to be particularly good here, just check that it's working, and it does seem to be. Just to make things a little bit more fun, we could also print out a sort of little message depending on how close the player gets. So sort of outstanding if they're really close, or dreadful if they do terribly. So let's create a string message, and we can set that equal to an empty string just with 2 quotation marks. So we'll want to set the message based on this error value. So we can say if the error is less than, say, 0.15, for example. Remember to add the f because it's a floating point number. Then we can set message equal to outstanding exclamation mark. Otherwise, so else if the error is less than, say, 0.75, then the message can be something else, like exceeds expectations. If the error is less than 1.25, then that's maybe just scraping by with an acceptable. If the error is less than 1.75, then that's quite bad. We can say message equals poor. And finally, for all other values, so we'll say else, we can set the message equal to dreadful. All right, so we'll just tack the message onto the end of this. So plus message, and want a space at the end of this other sentence here. So let's save that to see that it's working. By the way, if you happen to sort of click somewhere else, you'll see that it won't register the input. Just click on the game window and then it'll be working again. So our message is printing out, got dreadful for all of those. What would be quite nice is if it didn't start the next round immediately, so we had time to actually read our results. So let's create a variable up here called round start delay time. Can set that equal to maybe 3 seconds, should be enough. And then instead of calling the set new random time method directly over here and also over here, we can use the invoke method, which is something that we get from mono behavior. So what invoke allows us to do is just pass in a string for the name of the method and a float for the time, and it will call that method after that time is up. So we can say invoke, and then we need to pass it in as a string, so set new random time, and then we'll give it our round start delay time value. Okay, so we can delete this line now, and let's just copy this line and replace this with that. Okay, so if we save now, should see when we press play, we have to wait 1, 2, 3 seconds, and then the thing pops up. And once again here, we have to wait, and it pops up. Okay, so the game's actually working now, but since we added in this delay between rounds, it would be a good idea to ignore input while we're waiting for a new round to start. So let's create a bool to keep track of whether or not a round is currently playing. So we can say round started. By the way, as with sort of instant floats, which are initialized to 0 if we don't give them a value, bools are automatically set to false. So only when we call set new random time, which sort of signifies the start of a new round, will we say round started equals true. And then as soon as we receive input, that signals the end of the round, so round started equals false. And then we'll say this if statement only returns true if the space key is pressed down and, remember the AND operator we looked at last episode, that's 2 ampersand symbols, and the round has started. One last thing I'd like to talk about is just that we should really be thinking of our update method as a sort of command center. So when we're working on more complex projects with a lot more code, it's very nice to be able to just quickly scan through the update method and get a rough idea of how the program works. But that's difficult to do if we're filling it up with all the sort of detailed code. So what I'd tend to do is create a new method called something like input received. And then I'd take all of this code and put that inside of the input received method. And then inside of update, we just call input received. So now it's very quick to scan through update and see what's happening. We can see, okay, if the space key is down and the round has started, then we just handle the input. And then if the project was more complicated, there'd be more lines like that. And then if we wanted to go and see the specifics of exactly what happens when input is received, then we can go down to the method itself and read about that. We could also improve the readability of the input received method by further separating this whole message generation into a method of its own. We could have a method that returns a string, call this generate message, and it takes in a float for the error value, and then it generates this message, and then at the end, of course, we must say that it returns the message. And then over here, we can add the result of the generate message method, and we, of course, want to pass in our error value. All right, so I would consider this done. Let's save, and let me give this a proper try. So we are trying to wait for 11 seconds. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Not half bad. Not half bad. All right, see you in the next episode. Cheers.